How was this impossible structure built without machines? Imagine standing in front of a massive stone structure built thousands of years ago. Blocks heavier than modern trucks, perfectly aligned, standing tall even today. No cranes, no engines, no steel machines. And yet, this structure exists, untouched by time. The question is simple, but terrifying for modern engineers. Asterisk, asterisk, how is this impossible structure built without machines? Asterisk. Asterisk, what makes this even more shocking is that if we removed modern technology today, recreating something like this would be nearly impossible. So how did ancient builders, with what we call primitive tools, achieve something that still defies explanation? To understand this mystery, we first need to go back in time to an era where human survival depended entirely on intelligence, observation, and cooperation. Ancient civilizations didn't have written engineering manuals or digital calculations. Instead, they relied on generational knowledge passed through observation and experience. Architecture was not just construction, it was survival, religion, power, and identity combined into stone. These massive structures weren't built by slaves blindly stacking rocks. They were created by highly skilled planners, builders, and thinkers who understood physics long before the word physics even existed. Archaeological evidence shows that these workers were paid laborers, fed well, and housed in specialized villages near construction sites. They were craftsmen, not captives. From the pyramids of Giza to the megalithic temples of Malta, from Stonehenge to the precision-cut walls of Machu Picchu, each structure tells the same story: human ingenuity operating at its absolute peak. The biggest mystery isn't the final structure, it's the process. Some of these stones weigh anywhere between 22 over 100 tons. To put this in perspective, that's equivalent to moving 15 to 75 modern cars stacked together. They were transported across long distances, sometimes hundreds of kilometers, lifted to great heights, and placed with extreme precision that would challenge even modern laser-guided equipment. Even today, moving such weight requires advanced machinery, precise calculations, and controlled environments. A single mistake with a 100-ton block could crush dozens of workers instantly. So how did ancient builders solve this problem without hydraulics, without steel cables, without computer simulations? The answer lies in logic, not magic. The first secret was material intelligence. Ancient builders didn't randomly choose stones. They were master geologists who selected materials based on weight, durability, density, and how they behaved under pressure. Many structures use stones that naturally interlock, meaning gravity itself helps keep the structure stable, a self-supporting system that gets stronger over time. They identified quarries where stone could be split along natural fracture lines, reducing the energy needed for extraction. In Egypt, limestone and granite were chosen for specific purposes: limestone for bulk volume, granite for precision surfaces. The builders understood that different stones expanded and contracted at different rates with temperature changes, and they designed accordingly. The designs were simple but genius: wide bases, gradually narrowing shapes, and perfectly balanced geometry. This allowed the weight to distribute evenly, preventing collapse without the need for modern reinforcements. The pyramid shape, found across multiple ancient civilizations, is fundamentally the most stable structure humans can build. Now comes the most shocking part. Instead of lifting stones vertically, ancient builders eliminated vertical lifting entirely, or delayed it until the last possible moment. They used earth ramps, wooden rollers, sledges, and gravity itself as their primary tools. Recent experiments have recreated these methods. A team of archaeologists moved a 2-ton stone block using only ancient techniques: wooden sledges, rope, and water. The water, poured onto sand in front of the sledge, reduced friction by nearly 50%. What seemed impossible became merely difficult. Stones were dragged over prepared paths, using teams of workers pulling in synchronized rhythm, sometimes accompanied by chanting or drumming to maintain timing. In Some cases, causeways made of compacted earth and stone were built specifically for transportation, then dismantled after construction. For the truly massive blocks, such as those in Baalbek, Lebanon, some weighing over 800 tons, theories suggest the stones were never fully lifted. Instead, the ground level was gradually built up around them using ramps of earth and rubble. allowing the stones to be rolled or slid into position at the appropriate height. What seemed slow by today's standards was actually extremely efficient when manpower was abundant and time was not the enemy. Ancient projects spanned decades, even generations, and that was considered normal. Hash, precision without lasers. The astronomical advantage, another mystery, is precision. How did they align structures with the stars, cardinal directions, or distant landscapes so accurately? The Great Pyramid of Giza is aligned to true north with an error of less than 0.05 degrees accuracy that rivals modern surveying equipment. The answer lies in astronomical observation. Ancient builders studied the sun, stars, and shadows over long periods. They didn't need telescopes. They had time and patience. By marking seasonal movements, solstices, the rising and setting positions of specific stars, they created natural measuring systems far more reliable than any single tool. The Merkhet, an ancient Egyptian instrument made of a wooden rod and plumb line, allowed builders to establish precise north-south lines by tracking the movement of circumpolar stars. Shadow tracking using gnomons, simple vertical poles, provided exact east-west alignments. Instead of measuring centimeters, they measured time, shadow, and repetition, allowing astonishing accuracy through accumulated observation rather than instantaneous calculation. The final machine was not metal, it was human organization. Thousands of workers operated in synchronized systems that would impress modern project managers. Roles were specialized: planners who understood geometry, stone cutters who could read rock grain, transport teams coordinated like precision clockwork, alignment experts who tracked celestial patterns, engineers who calculated load distribution. This coordination functioned like a living machine, replacing mechanical power with collective intelligence. Communication systems used flags, horn signals, and relay systems to coordinate movements across vast construction sites. Evidence from worker villages shows sophisticated support systems. Bakeries that produced thousands of loaves daily, breweries for nutrition and safe hydration, medical facilities for treating injuries, and administrative buildings for planning and resource management. Modern construction depends on machines. Ancient construction depended on systems. And those systems were, in many ways, more resilient and adaptable than our mechanical dependencies today. Engineers look at these structures and ask an uncomfortable question. Did ancient builders understand construction differently? Maybe even better? Modern buildings prioritize speed and cost efficiency. Concrete structures are designed to last 50 to 100 years, then be demolished and replaced. Ancient builders prioritized longevity and balance. That's why many ancient structures have survived earthquakes, weather, and thousands of years, while modern ones fail in decades. The Pantheon in Rome, built nearly 2,000 years ago, still has the world's largest unreinforced concrete dome. It has survived when countless modern buildings have crumbled. The secret: a gradual reduction in concrete density from bottom to top, using progressively lighter aggregates, a technique that distributes stress perfectly. Ancient builders didn't fight against natural forces. They incorporated them into their designs. Earthquake resistance wasn't added as an afterthought. It was fundamental to the geometry itself. So, how was this impossible structure built without machines? Not through magic. Not through lost technology. Not through alien intervention or conspiracy theories, but through logic, observation, patience, and collective intelligence operating at a level modern society has largely forgotten. Ancient builders didn't fight nature. They worked with it. They didn't rush against time. They used time as a tool. They didn't depend on individual genius. They built systems where collective knowledge exceeded any single mind. They understood something we've lost, that the constraints we think limit us are often the very things that force us toward better solutions. The real mystery isn't how they built these structures. It's why we stopped building this way. Why did we trade permanence for convenience? Why did we replace collective knowledge systems with individual technical expertise? Why do we consider something primitive simply because it doesn't use electricity? Perhaps the ancient builders are still teaching us, even now. Thousands of years later, their monuments stand as silent professors, waiting for us to ask the right questions. The impossible wasn't impossible. It just required thinking impossibly different from how we think today. And maybe, just maybe, that's a way of thinking worth rediscovering.